Hey, thank you for joining. This will be just a quick tour through a couple of Hugging Face Spaces applications I created to help with vision language model research. So sort of the problem and the headaches I was having is that there's just too many papers to read. There, each week there's several models that are coming out open that are a fusion of, a vision and a language model decoder and some slight variances in implementation. And it was just a lot of work to kind of pull this information together. I was trying to summarize it in a paper, but these apps were easier for me. And I still might create a paper, but for now, this is meeting its purpose for me, and hopefully it's helpful for you as well. So this, initial sort of display here. Here are some of the key vision language models that are in use. Some of them have been around a little bit older. And this article, as you can tell, it's it's a couple of months old, which is like 10 years in human years. But some of the things that are missing, Moondream is here, which is cool. It's a very small vision language model, but I do not see PaliGemma from Google, and I don't see Microsoft's Phi3 vision model. So kind of gets back to the rapidity and how quickly things are changing in the vision language model space. This blog post is excellent from Hugging Face, though, in terms of describing the high level architecture, and it comes down to image encoders, the multimodal projector interface in between, and the text decoder that's implemented by the language model. So that's an important concept. And as I hop into the apps. So out in Hugging Face Spaces, there's two apps that I created. One is a Model Explorer, and the other one is the Hugging Face Extractor. So the Model Explorer, what it does, it leverages, a couple of Hugging Face capabilities. One is Gradio, which is the user interface that you see here, and the other is the Transformers library, which is, how you can sort of standard way of interacting and interfacing with a model. So that's what I use here to, be able to quickly sort of introspect and see the high level of details of the vision language model. It's not quite a pretty picture, but in some respects, with some of the stuff I tried to do with GraphViz, etc., that this view was the simplest, and also it was very easy to kind of go from this view that's output from the Transformers library into something more usable and professional. But anyway, this was a very quick head start. So here, this model that we're looking at is Phi3 Vision. And if you think back to what we saw before in terms of the standard layers for a vision language model, you have the vision encoder, and then you have the projection layer or the interface, and then you have an LLM that it talks to. So in terms of Microsoft's model, it uses a clip architecture, which is slightly different in terms of the next one we'll look at from PaliGemma's model. And let's just leave it at that for now. Okay, and so this is a different model. Here you go. Let's just go ahead and you can see it at work. So I'm using the examples to drive this. And so, very quickly, it's able to introspect the model based on the model definition. And here, this is for Google's vision model, it's using Siglet. For the vision decoder, it's using like a single linear layer in terms of at the projection or interface layer. And then at the language model layer, it's using Gemma. So often what I do when I'm trying to compare it, I'll put two models side by side on the screen and sort of compare interactively. just to show the code a little bit, and this is where some of the value came for me in terms of rapidly iterating and kind of understanding what's required to interact with the various vision models. And I mean, if you're thinking of being plug and play and sort of moving sort of Lego pieces around, this is a very quick way to understand how you can best interact with with the model. One of the key discoveries for me in terms of going through and digging in is that, the secret sauce of, what helps you interact with a model is in the config.json based on the standard transformers architecture. I don't want to belabor the point too much, but those of you that have worked with Hugging Face models will kind of understand the value of this. Most models, particularly non-vision models, you'll be able to load with a standard class, but there were a few that I found that used a specialized class, and in those cases, if the architecture, and this is kind of what was pulled from the config.json, if the architecture was of a specific type, like, if it was a lava versus PaliGemma versus Edifix, this is a vision model from Hugging Face, that anyway, for those that it did seem to have an issue with using the standard class, I was able to just quickly sort of switch it out to use something, use a more specialized class to load the model and to be able to view the architecture. The other quick lesson learned from, dealing with the Phi vision model and also just the Phi language models was that by default they're using flash attention. And so just by putting this logic here, it's able to leverage flash attention appropriately when required. So that's a quick sort of walkthrough of the Model Explorer. I think as you kind of go through, you'll kind of understand sort of what I was trying to do with this and, easily extend it to your specific use case. Things change so quickly that for me, that one of the essential things that helped me was that, you always get errors, and this is kind of like an error panel. And this is one of my favorite ones that I wanted to get working, but it was throwing an error, and it has to do with the specialized class that it declares not being found in the transformers library. So for me, that's kind of my next sort of thing to troubleshoot, but that's one of the other things. In terms of approach, errors are great. You learn lots from them. And in this case, I was able to catch the error and throw it here. The other thing that in terms of Hugging Face spaces is that it, provides an easy mechanism to be able to look at the logs. If it's not your space, you may not be able to see it. So if you clone it locally under your space, you should be able to get this working quite quickly as long as you have a Hugging Face Pro account. So next, let's hop into the extractor. So for me, as I said, that some of the key learning in terms of understanding, for the Model Explorer, how I can best sort of determine, what class do I need to use to be able to leverage, the specific vision model or even large language model. And so this gave a mechanism for me to like easily search. Right now it's focusing on space. So, all right, let's take a look at okay. So this is taking a look at a model, and now that I know that config.json has a lot of secret sauce, I can search for that. Okay, so in terms of the config.json, it calls out right away that the specialized architecture or class to use with, PaliGemma is this PaliGemma for conditional generation. And, anyway, that's kind of the value of this. Also, one of the things that I use like LLMs frequently for is to help do analysis. So even if I'm using like the UI ChatGPT version, I can copy this and paste it into ChatGPT and say, hey, introspect this architecture, how can I use it to do X, Y, Z? Or, if I copy the extract from 2, I can say, hey, compare these. So there's certain sort of shortcuts I took in terms of focusing on files of a certain size, because like for me, I was primarily interested in small files like config files so that I could use it for this type of analysis easily. So if you want to customize it for your purpose, you can clone the repo and adjust as appropriate. And so the other thing that was really powerful, like particularly with Gradio, does some cool things in terms of ability to create a very quick UI for multimodal use cases. As you can see, some of the icons may be a little bit small. You can use a webcam. You can, I guess audio isn't enabled for this one, but it's very easy to do it. And I've found that, finding working prototypes or examples that you like, and then, doing analysis on the files is much quicker and easier than reading through and scrolling through a bunch of documentation. So this is an example of a great demo that was created by Hugging Face and the Google PaliGemma team. And it's got some really powerful stuff in terms of vision analysis, but certain aspects of it were a little bit more challenging, but to code from scratch. And so I don't have it clear. So yeah, let me just do this. So I'll switch to something else. I'll ask it to detect a bee. So what it's going to do, it's going to take this image, and then in terms of this, what it's doing here is it's identifying and it's going to use a bounding box to indicate the location. So it's still thinking, but yeah. So here, what it's done, it's actually using the PaliGemma model and another model to sort of overlay this bounding box. And in terms of being able to segment cats, it's similar. They take a different method of sort of highlighting and segmenting the cats, but in terms of getting quickly to the point of understanding how that's done, and the code and the models to do it, that gets to the key sort of scenario. Like, so what I did here, the basis for some of the examples here is I took this and I cut and pasted it into the app so that it's no fun if you don't see me sort of find it. I mean, it runs so quickly, it's not even using a GPU to do this, but it's going out and it's pulling back the content. And the sort of what I have here, this is the app.py. So this is the main sort of logic. It's the Gradio app that's used here. But what you're able to do is you're able to take these examples, these prototypes that others have created, understand the approach that they've used, and then get to understanding some of the underlying secondary models used. Because in this case, for being able to do the bounding boxes, being able to do the sort of the overlay that's used for segment, it's here. So I'm not going to go into the details, but it's more just wanted to kind of go into the use case that, there's such brilliant and insightful work that went into building this meaningful demo. And, you can take these lessons learned and, leverage it to build, your excellent use cases. So huge shout out to Hugging Face and the Google PaliGemma team for sharing this. The other quick thing I'll show here is that on the Model Explorer page here, I've sort of documented some of the things that were so useful for me on my learning journey. And one is the link to the Hugging Face overview of VLMs. So that's what I showed right here. And then the other is a blog post on PaliGemma that kind of goes in based on use cases, how they went about their approach, and what the various use cases are meant to address and help address. So my last shout out is to the Google Model Explorer. This is something that I ran across at the time that I was trying to do the analysis. I couldn't get it to work for the vision language models, just based on how they do the model fusion of the vision encoder and the language model decoder. But it did work really well for large language models directly. So anyway, definitely worth following and paying attention to the evolution of this tool. I think that they will do it very well, and it's a completely different use case that I had in mind when I created my tools like the Model Explorer and the Hugging Face Extractor for discovery and analysis. So with that said, I'd like to thank you for your time and enjoy the rest of your day.